Greetings to you, dear friends. In this part, we will start with the introduction of resistors, and we will explain the resistors in two parts. We start with the question of what is resistance. Resistance is the main thing that is used in the electronic circuit to limit the passing current. And of course, there are other uses such as voltage level regulation using the resistance supply circuit. The discussion of pull-up, pull-down, which I will explain to you in full. It can be used for other purposes, but the main thing for us is to limit the flow. Here we have Ohm's law, which you must be familiar with. Ohm's law shows the relationship between voltage, current, and resistance. If we have current and resistance, the product of these two voltages is obtained. If we want the current obtained by dividing the voltage by the resistance. And if we want the resistance, it is obtained by dividing the voltage by the current. For example, suppose that we have a 3-volt battery and an LED which needs 25 milliamps of current to be the best lighting mode. We want the value of this. Let's calculate the resistance. Well, our voltage is 3 volts and the current is known. 3 times the current, the value of the resistance is calculated to be 0.12 kilo ohms. One of the commonly used circuit is the discussion of series resistors. Well, we know that the equivalent resistance is equal to algebraic sum of the individual resistances. If the resistors are connected in parallel, of course, the equivalent resistance between these two ends is the inverse of the sum. The inverse algebra of individual resistors and other circuit that we use is the resistance dividing circuit or voltage divider of this circuit, where we have a higher voltage level. For example, the input voltage, and we want a lower voltage level. A practical example is, say, 5 volts for the input circuit for an IC or 3.3 volts for our microcontroller. We can build such a circuit. Well, we need to determine this resistance. We want to note that the resistance divider circuit has various applications in electronics that we will get to know over time. In the following, I want to introduce the types of resistances to your service. Before that, we will make a division so that the mind is more prepared. I will introduce the resistances in 4 categories to your service. Deep resistors, which are normal or accurate resistors or resistors of different power. SMD resistors, variable resistors, and special resistors. Which special resistors are talked about more. Friends are less familiar with them, and I try to let me explain the part to you in detail. Normal or deep resistors. Let's pay attention to one thing. Why do we call these resistors that have a metal base and a line base? Well, this is actually TH. They are called through-hole resistors. But in general, in electronics, something that is common parts or ICs that have a base and go inside a PCB. That is, the PCB has one hole for each base. They are called deep or dual inline package. Another point is that ordinary resistors have different powers, and in addition to they are identified based on their ohm value. based on their power, there is another identification factor. For example, they say that resistance of 100 ohms in 1/4 of a watt. A resistance of 100 ohms is, for example, 1 watt, for example, 5 watts, 10 watts. Another thing is the different forms of resistance in the market, which I have seen in the picture. If we see deep resistors in boards or circuits, don't be mistaken. For example, don't say why this is flat. Why, for example, these parts are curved, which are classified in the category of normal deep resistors. Power discussion. What do we mean by the power of a resistor? For example, we say that our resistance is 1/4 of a watt. It is 1/2 watt. For example, it is 10 watts or more. What does this mean? We understood Ohm's law and said that we should not have one of these three parameters. Even if those two are known, the unknown is obtained. This table is a famous table in electronics that I brought here to give you an explanation. We have the parameters of voltage, resistance, current, and power, each of which can be obtained with three relations, provided that those three are known. For example, voltage is equal to current times resistance, or here resistance is equal to voltage divided by current, another Ohm's law. Or current is equal to voltage divided by resistance. Well, the main relationship of our power is voltage multiplied by current. Now, if we didn't have voltage, we can use these and put instead of voltage the value multiplied by the current multiplied by the current again, which becomes the resistance multiplied by the current to the power of 2. So another relationship for power is the same. For example, if we have the power, we want to the voltage, the power can be divided by the current. This is how to use this table. Let's check the previous example once again in terms of power. We want to see what power this resistor that we calculated was 0.1200 kilo ohms needs. Well, it was 3 volts of the battery. A voltage of the resistor is placed here. A voltage of current LED, which is clear. We assume that the power is equal to the voltage multiplied by the current. Well, we assume that the entire voltage is placed at both ends of the resistors. So we take the resistance voltage 3 times the current, which is 25. It becomes 25 milliwatts, about 1 watt. So we want a resistance of 1 watt. This is the way to calculate the power. What is meant by resistance power is that there are so many different power ranges for resistors available in the market. Power is transferred to the environment in the form of energy loss, which is heat. It gives heat to the environment. The point is that for the circuit that we want, for example, 1 watt, if we put a resistor of 1/8 of a watt, when the circuit is turned on, this resistor will get so hot that it will be burned. Well, in the continuation of deep resistors. Deep resistors are either normal or accurate resistors. Normal resistors that are shaped like this and are made of carbon, which determines the amount of carbon and its type. But these are precision, they are low. Their accuracy is determined from the last bar, which is usually around 10%. But the accurate resistors inside them are, instead of carbon, there is a resistance film and it is wrapped on that coil, which this technology can give us more precise resistors, and also it can create different ranges, that is different size of resistors for us, and that the accuracy of these is also higher, and this last bar indicates the accuracy, that their accuracy is 5% and 2%, and their color is usually cream color, and these are blue in color. I will continue the discussion of deep resistors by measuring and how to read the dimensions of a resistor. We said that our resistors are either accurate, blue colored, or inaccurate. Normal resistors have 4 color bands, and accurate resistors have 5 color bands, which is this color. A specified size of a resistor. According to this table, each color has a code. For example, this yellow resistor, which is the first color, indicates the number 4. The purple color becomes 7, and the brown color becomes the number 0 in front of these two numbers. In the same way, this is for the size of a 4 color resistor. Resistance, if our resistance is accurate, it is identified by 5 colors. In this table, you can see the resistor's standard size. And here you can see the brick deep resistors in different watts. Now I want to explain SMD resistors. SMD stands for surface mount device. That is the resistors that are soldered on the surface. The deep resistors have 2 bases that go inside the board. But the SMDs are soldered on the PCBs themselves. Sometimes they call it different names. There are different types of SMD resistors, whose powers and sizes I will explain below. Dimensions and standards of resistors. There are a lot of smaller SMD resistors in the market. Each of these has name. For example, they say 1206, 805, 0603. But something that is very famous and it is practical. There are mostly 1206 and 0805, which can be assembled by hand, but the lower ranges are difficult. Well, there is a question of their power. For example, a resistance of 1206 20, and there are 500ths or 8ths of their power. So their power also varies with their size. The bigger the size, the more power. But how should we read the SMD resistors? Well, they are also very easy. Their sizes are written clearly, and according to this table, it can be easily read. If there are 3 numbers, this is a normal resistor. If there are 4 numbers, it is an accurate SMD resistor. Like the accurate deep resistor that had 5 colors. If the number on the resistor was 4, it is easy to read according to the table. But there is one point here. Pay attention. If we had 10 ohms, this would be 1/10 of an ohm. If the R was on the side, this would be 68 hundredths of an ohm. If the R was in the middle, it would be 1 ohm, or 6 and 8 tenths of an ohm. It is the same in accurate resistors. Well, the SMD resistors are finished. Here I want to introduce the variable resistors to your service. I will explain the variable resistors in 3 categories for you, which are either potentiometers, multitrans, or in knobs form. The variable resistor in the schematic circuit is symbolized like this. A resistor with an arrow in the middle. The first variable resistors are potentiometers, which have both deep models and SMD models. What is inside this potentiometer? Well, every potentiometer has 3 bases, 2 main bases on the left and right side, and a variable base is the middle, which changes its resistance by turning this screw. Suppose here it is a resistor of 20 by 320 in front of it, which can be 20 kilo ohms. The first and third of these 2 bases are 20 kilo ohms is the resistance value. Now we turn this second base, which is the middle base, 1 round from here to here. It changes between 0 ohm and 20 kilo ohms. In this way, there are different dip models. The SMT models are also clear in the picture, which is the same. The point is that the potentiometer changes from this part to the end. The ohm value is done in one period, and well, this reduces the accuracy of work. For example, in a range of 20 kilos, it is very difficult for us to obtain, for example, a resistance of 22 ohms by rotating it. So what should be done? It is that in 25 to 30 rounds, this resistance range changes. And these 2 bases, the first and last, have the entire resistance range. The middle base also varies between 0 value and the final value of a resistance. And the value of the Multitran resistors is also clearly written. For example, it is written W102. It is 1 kilo ohm. I will tell you how it is inside the Multitran resistors, so you can see the same variable part. But this time, by turning this potentiometer, this screw of the Multitran passes small steps to move in this part. And the 25 or 30 steps it passes increase our accuracy. Let's go to the knob resistance. It is used to adjust the different resistances. There is a model on the board that is soldered on the board, or a model that is soldered with the wire, like this photo, and the inside of the figure is like this. Knobs resistors are like potentiometers, but usually these knobs and potentiometers cannot be used for precise work. For precise work, we use multitrans, which are more expensive than potentiometers. Now I want to explain the SAW resistors. These resistors have 2 models, or they have a common base and there is a resistance between each of them. For example, it says 470 kilo ohms between this common base, and each of these is 470 kilo ohms, or they don't have a common base. This is a deep model. It also has an SMD model, and it is used on circuits that require a large number of resistors. For example, you can see in this board that this IC has each of these resistors next to it. The same number it was supposed to take up a lot of space on the board. Well, this part of resistances is over. In the next part, we will see the continuation of the resistances together. Stay with me and like and subscribe to my channel. Thank you.